In this video, we are going to try to understand how YouTube managed to scale to 2.49 billion users with a MySQL database. We'll try to understand the system design of the YouTube and going to figure out how YouTube leverages the MySQL database to store the video data very efficiently. So let's get started. Once upon a time, three engineers working on a PayPal decided to build a dating application, and this business model failed, and that's why they decided to switch it from a dating application to a video sharing application, and they named it as a YouTube. So they had a lot of video data that they store in a MySQL. They store video titles, description, and the user's data, everything into a MySQL. As more and more users join, they set up a MySQL in a leader follower replication topology because they wanted to scale. So they utilize this topology of a leader follower where they will maintain a multiple instances of the database, and as the video data will keep on growing, they will continue to scale up these databases. But there was a huge problem in this architecture because it was a basic setup of the leader follower replication, and the way a replication work in a MySQL, it is a single threaded. So follower couldn't keep up with the fresh data on the extreme right operation scenarios to the leader. Imagine you have a multiple instances and a leader is a master database and the follower is maintaining a subset copy of it. If you scale to a large scale, then there was a bottleneck in or extreme write operation to the leader, and a time at which a YouTube was released, the growth rate was very explosive. So YouTube team decided to find a solution to this, and as action they decided to scale out by adding a cache and preloaded all the data in the events from the MySQL binary log. This means that like a replication becomes a memory bound and a faster. So by adding a cache, it speed up by some extent, but though it wasn't enough because the data that was keep on coming, it was growing exponentially, and they needed a concrete solution for this problem. Then entry of Vitess happened. So Vitess was a tool that was being developed by the YouTube engineers to solve this problem, and it was focusing on handling a lot of data and a traffic that was coming to a MySQL. It had a unique property to do automatic sharding, which will help to grow a database without adding a custom sharding logic by our own. So in a nutshell, Vitess is like an abstraction layer on top of a MySQL for a simplicity and the scalability. So let's try to understand how Vitess actually works. A Vitess has three fundamental components at its core, namely VT-Tablet, VT-Gate, and Key Value Database. First is VT-Tablet. This part sits in the front of the each MySQL instance to manage the backups and speed up the queries that are happening on the MySQL database. It takes care of the speeding up the queries, managing the backups automatically. VT-Gate. This acts like a traffic cop, directing data requests efficiently and making MySQL look like a one system. So essentially, VT-Gate takes care of directing data requests efficiently among the multiple instances, ensuring the efficient communication between multiple databases and making them appear like a one big system. Key value database particularly stores the metadata about how your database instances are organized, how they are split up so that VT tablet can make a queries to a specific instance of a MySQL database. And when it comes to interacting with the database, Vitess take care of each and every area where they can optimize this interaction of a data retrieval. They manage to control the MySQL server and the database backups, wrote a logic that will take care of rewriting the expensive queries by adding a limit clause to each of the queries so that a data return is not a huge in a size. Cache the frequently accessed data, a data that is being retrieved very frequently, which they kept in a cache to prevent the thundering hard problem, which is a problem where you retrieve a same data again and again, which is huge in a size, causing a delay in your queries. At the client side, they managed to keep the MySQL connections very low using the connection pooling and sharing the connection wherever possible. So for a client, it was like a single monolith MySQL server, but internally Vitest has this distributed architecture. It also limited the number of transactions that are happening at a time for a better performance. However, the important part of this architecture was to maintain the state information, and that's where a key value database played an instrumental role. And this key value database was running on the HTTP server to keep up the key value database updated so that whenever any updates happen, each and every instance of a database will have a fresh copy of it, keeping all the instances in a sync all the time. And now today at this date, Vitess is capable enough to scale out to any level by just adding a more VTGate servers and updating the key value databases so that you can have the information about your servers. So thanks to Vitest on MySQL, because of which we have a YouTube today on which you are watching this video can handle the billions of users very smoothly. Vitest is an open source tool that you can try out, and it also supports a MariaDB, so you can plug it with a MariaDB database and you can try to develop something very custom for your need. If you like this video, then subscribing to my channel is a really great way to show us support, and thank you for watching this video.